Let's do some hypothesis testing, and we'll do it with some cards today. I do have a scenario. Actually, I have a couple scenarios for us. A friend claims to be a master shuffler, but you suspect they might be using sleight of hand to stack the deck, making it more likely to draw low-value cards. You want to test if the deck is indeed stacked low. This definitely sounds like something that we can do, and we could probably just do it in Excel. First thing we want to do is go ahead and get a sampling of our random cards. So I have this stack of perfectly shuffled cards from our friend, and we'll check out what kind of values we have. So the first one we have is an ace, 2, 4, 2, 5. Oh, these don't seem very high. King, there we go, 13, 3, 6, ace, and 4. Let's go ahead and put this into Excel and see what we have. I've opened up Excel and already done some of the work ahead of time. Let's explain where I'm at. I started off by just creating a couple columns to explain how the cards are scored. So we have a card column and a value column. The cards are numbered from ace, 2, 3, all the way up to 10, jack, queen, and king, and we've assigned the values respectively. Ace with a 1, all of the numerical cards as assigned. Jack is 11, queen is 12, and king is 13. That is one suit of the cards. Remember, there are 4 suits. So 91 total points per suit times 4, that's 364 total points throughout the deck of cards. That means that on average, when we pick a card, the mean value of the card will be 7. That's what we expect from a perfectly shuffled deck of cards, that we're going to get that mean average. Well, mean. We're duplicating ourselves by saying that. We have created a hypothesis. We need to have our null hypothesis. So H0 is that the deck is fair. We're assuming that we have a good, fair deck of cards. Whereas our alternative hypothesis, H subscript 1, would be that the deck is stacked unfairly. I have now entered in all of the cards, our sample, the 10 cards that we went ahead and drew earlier. Let's find out, what is the mean of these cards? Is this falling in line with what we would have expected? Well, we expected to have an average of 7. Instead, we ended up with 4.1, which certainly seems low, but we don't know for sure if that is statistically accurate or just really by chance. We can do this in Excel by running a t-test. Unfortunately, Excel does not have a single one-tail t-test, so we actually have to do a 2-tail. In order to do that, we're just going to create a dummy column right beside our actual data, and we're going to fill it with the expected mean, which is 7. So copy that all the way down. We can run our test by data and data analysis. The t-test, we're doing the 2 sample, assuming unequal variances. For my first column, I am going to select the 10 cards that we selected. For the variable 2, I will highlight the dummy data. And I do not have labels. I'm going to keep my alpha at 0.05, pretty standard. And for my output range, I'll just put it right beside where we're at. And we'll drop this in. Let's take a look at our results. We do have some information about the individual columns, the mean, the variance, the number of observations, as well as our degrees of freedom. The first statistical measure that we see is the t-stat. It is negative because we find that our value that we have gotten, that we're showing 4.1, is less than what is expected. So that is the minus portion of that. The actual number, the 2.589, that's the magnitude. That shows you how far the strength of the difference is. It's between what we actually saw and the random variation, the noise that we would expect. So that seems pretty high. The next value, this one, is our p-value. Because the p-value that we are observing here is less than 0.05, we are going to reject our null hypothesis. This is showing that the deck is fair. We are rejecting that. So we are thinking that our friend might possibly be wrong, might not be giving us good information. There are more ways than one to test on this. Let's also take a quick look at Jupyter Notebook. I've already put this into Jupyter. I'm going to verify it by using the stats module I'm importing from SciPy. I've already created my array with the 10 data points that we've seen. I need to pre-fill the population mean. This is what I am expecting the population mean to be, which is 7. And then I can very easily go ahead and run the test. I'm going to print the t-statistic as well as the p-value and get a conclusion from this. And I've hit the run. We're importing our 2 modules and hold on, we're all so excited. We can find out, got a slightly different value there. I think I might have entered the cards wrong, but we're finding the same results. Our t-statistics definitely on the minus 2.5 area, and our p-value much lower than expected. The deck appears to be stacked. We have another scenario that we can do a test for. Here we're playing a 4-person card game. The same person deals every hand, but you notice that player 3 seems to win an awful lot, and you suspect the dealer might be using sleight of hand to give that player better, higher value cards. You want to test to find out if the dealing is fair across all 4 players. This seems like a great scenario for trying out in an ANOVA. I've opened up Excel again and pre-filled all of our 4 players to represent which cards have been placed with each player. We can do just some quick back of the hand kind of math here. Let's just do an average for each one of these and see if we see anything suspicious. 4.9, 5.7, 10, 4.3. That definitely seems pretty suspicious on my part. When we're working with our data science and our statistics, we do need to set up our null hypothesis. So what is the null hypothesis? Be that all hands are dealt fairly. And our null hypothesis would be that all hands are not dealt fairly. We have that. Excel does make this quite easy to display in an ANOVA. We can set that up by clicking on data and data analysis. This is going to be an ANOVA single factor. Click on that, choose my range. I'm going to go ahead and select this with our rows, or with our headings rather. Can include that. And I'm going to let it know that I do have it grouped by columns. You need to make sure that if you're using by rows that you select rows, but we do have columns. I've selected labels in the first row. And our alpha is 0.05, very standard for us. Our output range, I would like to just show up right here on the sheet that we're working with. And okay, here we go. You can see that we do have even columns. We have 13 count for each of our columns. We can see the sum, we can see the average, we can see the variance for them. And Now we can go ahead and take a look at our actual analysis. The key things that we're looking for on this, of course, would be maybe our F value, our P value, and we can look at the F critical as well. Oh, I need to move out of the way here. Downsize this so you can have a better look of what we're analyzing. Back over to here, this was our F, or our P, and our critical value. So let me make sure that I'm not lying to you here. We want to make sure that we are justifying this properly. The p-value, we can see that this value is extremely small. That is certainly going to be below our 0.05. It's going to be closer to 0.000 or so, indicating that, once again, we are going to have to reject our null hypothesis, which makes us believe that the hands are not dealt fairly. And it's pretty evident. We didn't have to do a statistical analysis to see that there was a problem here, but this gives us some proof to go along with it. We can do the same thing in Python as well. Python gives us lots of power for this. I'm going to do this with, again, just using our stats module from SciPy. I do need to import the data for our 4 players. For this one, we're just going to use the F1 way. That's going to be our ANOVA. And we will get our F statistic and our P value straight from the module. Here's our calculated F statistic, 17.0344, and our calculated P value of 0.00, and so on. It's a great example of finding out how we can use statistics to find out that our friend, who's supposed to be a super honest dealer, might be cheating us. We might want to be careful about doing any gambling with this particular friend. So thanks so much for watching. I hope you enjoyed the video and that you found it informative. Take care.